I have written quite a few books about programming languages, including Core Java, which is now a true classic. Came out right when Java came out, way back when in 1996, is now in its 11th edition. And at one point, I started having to write a lot of JavaScript. And that's, as many of you can imagine, an experience for a dyed-in-the-wool Java programmer. And so I fully expected to hate JavaScript. And it turned out that I didn't. That, sure, there are some weird features in JavaScript, but if you don't use them, and no one can force you to as a programmer, then JavaScript is actually a perfectly fine language. So I ended up writing a book about my journey to JavaScript and the recommendations that I like to give to people who come to JavaScript from another language and who want to just use it without having to experience all the bad parts. So today I'm going to be talking about one of the chapters in that book about async programming, which is, of course, a hugely important subject. So I'm assuming that you all have some experience with JavaScript, that you want to learn about modern asynchronous programming, everything that there is to know in JavaScript in under 3 hours. So we'll be moving at a fairly fast pace. The question usually comes is, where can I download the slides? So these are actually HTML slides. You should have gotten a URL in your chat. So just download the URL that you see here up on the screen, or copy and paste it from wherever it was communicated to you. If you can't find that URL, put the question in the chat and we'll help you out. And then as there's code in the slides, you can just copy and paste it into whatever programming environment you want to use. So we're going to go through, you know what, in the interest of time, I'm not going to tell you what you learn. You'll figure it out when we get through the course. So you learn the usual thing about asynchronous programming, promises, async, await, and many, many of the pitfalls that come with these topics. We'll have this talk in a number of parts. At the end of each of these pages, we'll have a short break for everyone to do whatever they need to do. So there should be about 4 breaks in the course. And so with that having said, let me just get right going. So let me look at some typical code here. Here I'm loading an image. So this would be some code that you would run in a browser. We have a function that adds an image. The image URL is given, and one adds it to some element. You don't have to know all the details. This just uses in plain old HTML, HTTP request. It's asynchronous, of course. We send a request, and eventually we will get the image loaded. So if we look at the code here, when we call request.send, then the request object sends the request, and we get execution flow comes right back. And eventually the image data will arrive, and then the callback here that we see in here is going to get triggered. Again, it's not important that you understand the exact protocol of an XHR request. These days, there are libraries available that make this much more convenient. But the principle is always the same, that these requests are by their very nature asynchronous, and the data comes back in a callback. So now let's say we add multiple images. So we call this function here 4 times. And what's going to happen? Well, the first call is going through all of this code that you see over here. It calls request.send, and then, of course, it returns immediately. Then the second call is being made. The second image request is fired, the third, and the fourth. Eventually, one of them succeeds, and the handler kicks in, and some image is being assembled and appended to this HTML element. In which order does that happen? Who knows? It could come in any order, because we don't know which of these 4 URLs gets loaded fastest. So I just demo this here really quickly, and you can do this at home as well. And if you have the slides, just click on this thing, and we'll see. So now they came pretty instantaneously. Now They seem to come in this order. Now you can see sometimes the order actually changes. If you paid attention to these slides, these are Japanese card games. And I just happen to know that this here is number 1, this is number 2. And so they don't necessarily come in order. And because my code simply says append it to some div, they will show up in whichever order they happen to come. That's just the nature of them being asynchronous. We'll later see if we want to assemble them in order, how we would have to do that. I just want to demo right now the non-deterministic aspect of this. All right. So let's talk a little bit about the very basics of asynchronous programming in JavaScript. So JavaScript is single-threaded. That means that you will never, as a programmer, program 2 tasks that run concurrently. Something happens, then it's finished, then the next thing happens, and so on. So every time that you write a function in JavaScript, that function runs to completion. And then something else happens, but you will never have 2 things happening concurrently. And that is really a good feature. It makes it very easy to reason about the correctness of your program. There can be no race conditions. So it often happens that inside a function, I will disassemble some data structure, and then I'll put it back in order. And I know that function is going to run from the beginning to the end, and no one and nothing is going to interrupt it. So the fact that temporarily the data is in some disheveled state doesn't matter at all. If I did this in Java, this would be really problematic, right? Then I would have to worry about, well, what if some other thread concurrently executes the same function or a different function that operates on the same data structure? Then bad things could happen. So in JavaScript, you're completely freed from that. So in this presentation, you won't hear anything about locks or mutexes or any of those things, because concurrent access is not something that we have to worry about. Now, one might say that these things exist for a reason, but in the world of JavaScript, it's just not a concern. And it really simplifies the programming model and the mental load for the programmer tremendously. So another thing in JavaScript is, because there's only a single thread, of course, that thread better not be blocked, because otherwise nothing is going to happen in your program. So in a JavaScript program, you can never block for anything. If you need some data that's not instantly available, then that data will have to be supplied in a callback. There is no other way. There's no way in JavaScript really for saying, let me wait. I mean, of course, there could be, but we never want to program in this way. Anytime that anything is not instantly available, we want the answer whenever it is available through a callback, because otherwise our one single thread cannot make progress. So that does have the unfortunate corollary that if you want to do things in order, like let's say you want that first image to arrive, and then that second image, and then that third, and then that fourth, you might have to do callbacks inside callbacks, right? After the first thing has happened, then you want to schedule in the callback that happens when the first thing has happened, the second thing. And so you get the code that looks like what you see there on the right. You're not supposed to read this code. It just shows the pattern of the code that you get when you have callbacks inside callbacks. So you have this very characteristic indentation where it gets nested more and more, and the code path gets really complicated if there's some ifs and some elses. And when you have error handling tossed into the mix, then an exception handling, then it gets really bad. And so this is rightly known as callback hell. So the entire purpose of the asynchronous programming features in JavaScript are to deal with the issue of callback hell. So this talk goes in 2 stages, and it does somewhat follow the evolution of JavaScript, which I don't normally like to do. Normally, I don't like to drag people through, here's first the not so good part, and then there's the better part, because people are busy and impatient, and they just want to know, well, what's the right part? But it turns out that in the case of asynchronous programming, the right concept, which is async await, is brittle enough that it's hard to understand it fully without understanding the promise concept on which it is built. So that's why we're first going to make this seeming detour to promises, because they really are necessary to fully understand the finer parts of async await. So what's a promise? It's a simple concept. A promise computes a value or an error in the future. So when you are given a promise, hang on to that promise, because at some point it's going to give you either a value or an error. The reason that we have promises is they're easier to chain together than callbacks are. You can chain callbacks. You can make a callback inside another callback, but as I've just said, it makes the code awkward. And so with promises, they're explicitly designed to make that chaining more convenient. So before we experience that benefit, let's quickly see how one can make a promise. Now, I'm going to tell you that, and maybe that's not so great, because in most of the time, when you write code using promises, you don't even see that part. Some deeper part of some library makes a promise. You're being handed that promise, and then you're in good shape. Then you have this thing, which, as you can soon see, you can chain together nicely. But still, let's get started and see how you could make a promise with your bare hands. And it's a little bit complicated. To make a promise, this really is what you would do if you were a library writer who needed to turn regular JavaScript code into the world of promises. You have to provide you have to invoke a constructor, the promise constructor. That promise constructor is given a function. We see that function here. I write the function here as an arrow function. That function has two arguments, which themselves are functions. So here we have a function, there we have a function. Where do those come from? We have no idea. When the JavaScript runtime invokes this constructor, then it will be manufacturing these two functions. So what we now have to do is we invoke our callback in the normal way. I should say we schedule our callback in the normal way. We make the callback that does something. We'll look inside it in a minute. Then we invoke the task, whatever that task may be, like making an XHR request, starting a timer, or whatever. We invoke it in the normal way. We give it a callback, and that's the callback that you see here, where we now figure out in the callback, well, were we successful? And that, again, is different for every task. If it's an XHR request, there's a way of finding out whether it was successful or if it was something else. It really depends on the details. If it was a timer tick, they're always successful. So if you found that your task succeeded, then you invoke the resolve function with whatever the result of your task was. Otherwise, you invoke the reject function, and you give it whatever exception you had, or you might want to make an exception object to notify the promise of failure. So this is the framework that one has to do. Again, it seems convoluted, and you almost never have to do it, but it is a good idea to once know how that works. So let's do that with the image loader. So what I want to do is I want to rewrite my function that loads an image so that instead of just loading the image and going away, that it returns a promise that I can later use to get the image. So here's my load image function. It takes a URL. In the previous version, I just went away, and so I had to give a second argument, namely the HTML element to which to append the image when it finally arrived. In this case, I actually kind of want the image, except I can't have the image since the image is not arriving synchronously. I can only have the promise for an image. That's the next best thing. So I want to have the promise for the image. So I'm going to return a new promise that is constructed from this function. This is a function that has two handlers for the good and for the bad part. And now in the body of that function, I do what I always do. I launch my task, I give a callback. So over here, just take my word for it, this is what I've always done before to launch this task. And so somewhere I have a callback, it's here. And now I have to program my callback. The callback is different now. I have to not only do what I've always done, namely in this case, assemble my image, but I also have to invoke the resolve or the reject function. The resolve function here, I pass the image, and that'll be the case that the promise is resolved. In the reject part, I pass an exception. So here you see an exception object, an error object that is then in the bad part. So that's how it works. Let me give you another example, and that's the last time that we'll have to do this. What if I just want to use a timer? So, and we'll do that for a bunch of experiments. So you'll probably have to copy and paste this if you want to follow along with the code later. So here I just want to produce a value after a certain delay. So the way I want to do this, I want to call produce after delay. I give the value that I want to produce, and I give the delay. So this thing is going to give me a promise that says, hey, I promise you the word hello, the string hello, in 1,000 milliseconds. So the logic is again the same. We have to call the promise constructor. We call it with this function here. And the function, this function will be invoked, not by us, but by the runtime, with two callbacks, the resolve and reject callback. I now have to do my timeout the way I always do a timeout. I call set timeout, I give it a callback, and I give it the delay. And in the callback, now I don't have to really worry about failure, except the way I'm doing it here is that if this argument here, the first argument, if it's an exception, then I'll say that means a production of failure. So if it's an error, then I'll call reject, and otherwise I call resolve. And I just feed either the exception object to reject or the value to resolve. And that's how the promise is going to be constructed. Like I said, we don't, after this, we don't have to manually construct promises anymore. We now have a couple of functions that do this, but we have something that we can experiment with. So the control flow is convoluted. So let's see what happens, and I'll do it in the simpler of the two cases here. Let's see what happens when I call produce after delay. We get into here. So the promise constructor is called. Let me blow this image up a little bit. So that's where we're right here. The promise constructor is called. Now, the next, the promise constructor then is going to be invoked with with that function that's inside it is going to get invoked by the runtime. And what does that function? The function is, by the way, often called the executor function. What does that function do? It launches some background process. That could have been an XHR, that could be just a timer task, or anything else that's asynchronous. So that background task is launched. And then, of course, the constructor returns. The function in which we called the constructor returns. It returns the promise. And then the main thread just keeps humming along and does whatever. It'll invoke some other function, But eventually, the background task is complete. The JavaScript runtime will, when there's some kind of pause of the main thread where your code is not running, it will then run the callback. Whenever it does this, it'll then schedule it on the main thread, and so the code in the callback will run. So that way, that will then either call resolve or reject, which then goes back into the internals of the runtime and it'll do something in the promise internals, and then they will invoke some other code, and we'll see in a minute where that code is, because that's the code that you need to schedule so that you can actually harvest the promise. So it is complicated, and no one gets this the first time. We will come back to this more than once. So I have here a list of all of this, of what I just said, and like I say, we will come back to this. So a couple of things that one needs to be careful to be sure about when one writes these promise constructors, and again, we're not writing them very often, is, well, what would happen if I go back to the constructor here, for example, what would happen if in this callback here, I never call reject or resolve? Then that would be bad. The promise will never be fulfilled. In this code here, that means that the user now holds a useless promise object in their hands that they can never really do anything useful with. A little hard to imagine for us yet because you don't yet know how one does anything useful with. So we'll, again, come back to that. We will also later see, which I say here is a somewhat uncommon case, that a promise can return another promise. And, well, we'll just see what happens then. We don't have to go into the details right now. So let's come to the actually interesting question. And that is, how do you get the result of a promise? Someone has given you a promise, you're holding it into your little hands, and that promise says, I have a promise to give you an interesting result back real soon now. What do you do with it? You can't ask the promise, hey, I just wait until the result is available, because in JavaScript, you can't wait. All you can do is what you can always do in JavaScript. You can provide instructions what to do when that happy event finally happens. And the whole point of promises is to make that as convenient as possible. So a promise has a method called then, where you specify the action that should happen. So let's have an example. I make my promise. This is, I call the load image function. The load image function gives me a promise for an image that will come later. I will then take my promise and say, hey, little promise, when that finally happens, please run this code. So it looks just like a callback. Doesn't look like so far there's a lot of gain, but we'll come to that. So this code is as simple as it could be. Its argument is the thing of value that the promise promises to give. And then inside there, we do whatever we want to do with it. Like here, I'm appending it to some HTML element. Here I have another example. I'm calling this function here, which promises to give me 42 after 1,000 milliseconds. And I take this promise and say, well, when that happy event finally occurs, then invoke the function console log. The argument of then is a function. If I happen to have a function that does the right thing, here console log will take an argument and log it on the console. Then I don't have to use the arrow notation. But most of the time, of course, you will need to use the arrow notation because you'll need to do something custom that you don't have a function for. If you like, you can always use the second version where you pass an explicit function and then just implement that function somewhere else. But most people will do this arrow thing. All right, so that is how you can get something of value out of the promise. And it's the only way. There's no other way to get the thing that you want from the promise. You tell the promise, hey, when it arrives, then do what I'm telling you. And so again, what is a promise? A promise is a thing that computes a value or an error in the future, and that when that value or error is finally available, whenever that may be, then it invokes a handler. That really is what a promise is. It's this promise to produce something and then forward it to a handler that you nominate. Where do you nominate it? In the then function. All right. So that's really all. So let's have a little demo here, and I'll just do this in Node.js. So actually see if we had a few questions here. Okay, so there's a very good question, and that is the function provided in the then different from the callback? And yes, it absolutely is. So let's have a look at the, that really is a very perceptive question. So let's look at the case of the image handler for a second. So over here, I said, and I'll start here because this is the part that's easier to understand. So I call load image, and it gives me a promise that says, hey, you will soon hold an image object in your hands. Then I use that promise and say, well, when that comes, call this code. So this is the handler that I want in the user code. I, as the user who wants to put images in my somewhere in my DOM tree, I call load image, and I say when that image arrives, then I want this. This is the way I want it. If we go back to the implementation of load image that some library writer wrote, so let me go back to my library writer hat. There's also a callback involved, but it does something completely different. The callback that's involved here is the callback for the XHR, for the web request that's put here. Here, the library code says we must make a web request to get the image. And when that image arrives, then one must do whatever one then does, decode it into some JavaScript object. We're constructing an image, we're setting its source attribute, and now we have this image in our hands. And now one wants to return it to the caller, except you can't really return it to the caller because, let's face it, float image has long return. It has returned as soon as the request was made. The way that I, as the library writer, have to return it to the caller is to invoke the resolve function that was handed to me at one point. And so I call resolve, and then that image somehow gets transported into the innards of the JavaScript runtime to reappear when my code here. When this then function has its callback called. So there are really two callbacks. There's the library callback that says how to move the data onto the promised machinery when it arrives. And then there's the programmer, the application programmer level callback, where when the application programmer, who doesn't want to have anything to do with this complex back and forth, when they say, well, when this image arrives as an image, which has been produced for me, then that's what I, in my application, want to do with it. So it is useful most of the time to think about this application level, because that's how you're going to be using promises. You're going to be writing, we're going to be having a promise, and you're going to be called in on it. Let's see how we're doing here. Yes, so it says resolve is passing the value to then, and so it's a good way of thinking about it like that. So resolve is kind of passing the value to then. It's not really passing the value to then, because what really happens is that the runtime orchestrates it so that, okay, let's take this slowly. What does this even mean? This means that a method is called on the promise object. The argument of the method is some function. That function is now stashed away in the inner guts of the promise object. And the code here moves on to whatever the next line of code is. So that's all then does, technically. Then doesn't wait or anything, then simply stashes away a function, a callback, for later invocation. Then the JavaScript runtime will, when the, as you said, say it correctly, when the resolve function is invoked much later, then it'll say, oh, didn't this promise have a callback? And then it'll invoke that callback with the argument being the value that was given to resolve. So the details are complicated. One doesn't, after a while, one kind of doesn't think about it too much. One simply thinks about the fact, oh, eventually, this will happen, and this is the action that we then want to take. What about rejection? We'll see that in a few minutes what happens with rejection. Let me not muddy the waters with that right now, and I'll come back to it. All right, so let's do this here. Node. And so I'll show you. I'll do it in Node first, and then I'll also for kicks do it in the browser if you don't have the Node installed. So here I'm copying my function into Node, and now I issue this call, and you see it says promise pending. That's what I get when I call a promise. I just have the promise. Nothing actually happens with it. If I want to see what the promise has given to me, and I've been talking for more than 1,000 milliseconds, so surely it has given me something. There's only one way to find out what the promise has given to me, and that is I have to call that. You can see here, by the way, that that Node knows already what's happening. It's telling me here, but that's just the Node environment. That doesn't mean I can use it in my code. So I say promise then, and then console log. And then you can see the hello appearing here. So let's use two promises. Here I'm having promise 1, and it's pending, of course. And now I'm going to make a promise 2, and it's also pending. And now what I want to say is I want to multiply their two results. That's not all that simple. I have to pick one of the two and call then on it, because after all, the only way to get the value out of a promise is by calling then. So I start with promise 1 and call then, and X is the value that it has. Then I have to fish it out of Y. Oh, sorry, out of promise 2. And again, the only way to do that is to have a then. So I have a then inside a then here, so to speak. And then I have that thing as Y, and then I can finally get the product. So the whole thing is like this. And of course now, because I've been talking for more than how many thousand milliseconds? I should really have it as a question here. So the first one here took 1,000 milliseconds, and the second one 2,000 milliseconds. They do run concurrently. So after about 2,000 milliseconds, the answer should have been ready. Let's see if this was confusing enough. So here was another great question. So first of all, what if you have multiples then on one promise? We'll see that in the next slide. That's a very good question. And the other question was, well, what if the promise finishes loading before it gets to the then line? So that is almost certain not to happen. And so let me explain why that is so. So let's follow this call here blow by blow. I call load image. So that means I am back in this function. What happens? This constructor here gets invoked with a function. This is just an object. It's a function object. That function object is put somewhere. Notice that the function is not yet called. It's right. It's just a function. It's an object. And so that object gets stashed away somewhere. The constructor for promise returns immediately. So the object that has been constructed somewhere in its innards now has this function object sitting inside. But it returns absolutely immediately. So that means that at this point here, my load image function here is done. And by the way, I lied about the function. The function is this whole thing. So the function is this whole thing. And so the load image function is done. Immediately afterwards, we call then. So the thing that's inside the constructor hasn't even been invoked, and we're already calling then. So it is super unlikely that, in fact, it's impossible, that the image would have already arrived. At this point, all we're setting up is this chain of handlers so that the JavaScript runtime can do the right thing when we finally stop doing stuff. So all of the code that in your JavaScript program must be in some handlers, maybe in an onload handler or something, and pretty soon it's done. And then the JavaScript runtime can breathe a sigh of relief that you've stopped coding and it can do something again. And then it's going to start invoking these functions in the promise constructors. And eventually there'll be callbacks that cause more stuff to happen. So that's a difficult thing about dealing with these promises, that one always has this feeling, that there is a certain order of flow, but the flow order is the one that you always have in JavaScript. Bam, bam, bam. You do one thing, another thing, another thing, and only much later these various things happen. So whenever you see something like this, or for that matter, something like this, you have to realize that all that code does not yet run. Anytime you see an arrow, that means the execution of that code happens at some later point. All that happens at this point is that the promise constructor gets called, this function is stashed away, the promise constructor returns right away, and we are here calling then to stash away yet another function. All right, now I've forgotten the question, so let me make sure that I even answered the right question. So I think I'm done with this, that the promise cannot finish the object before it gets to the then, because the then does not, it happens right away. It's a little bit misleading what I do here in the node interpreter, which is a special beast. In the node interpreter, of course, because I type so slowly, it can happen that I have this promise object in my hands, and then I call then, but that's not really what happens in your code, right? In your code, this happens all without any interruption at all. The node interpreter will run one line, and then in the background, other stuff can happen. All right, so, would it be okay if, for whatever reason, like in the node interpreter, what if my answer is magically done quicker than I thought? And yeah, sure, it's okay, right? Like in this case, you have produced hello after 1,000 milliseconds, and then for whatever reason, I didn't do anything, and then when I invoked then it was already there. And that is then up to the JavaScript runtime to say, oh yeah, the promise already fulfilled, I might as well invoke this handler on it immediately. How that exactly happens that's Node's job, but yeah, that'll happen, and it's perfectly fine. All right. So is the result saved? That's also a great question. The result is not saved in any particular way. So let's look at the code that we have here in Node, where we're making this function here. And so now I'm executing this line here. So what I have done, I have called produce after delay. What did produce after delay do? It constructs a new promise, and the promise stashes away this function. And so that's my promise object. Now, because it's Node, the JavaScript runtime has a chance to start doing something. So at this point, it will say, yeah, there is this promise that's been constructed. I better kick it off by calling the executor function. The executor function will get called. And so this function here will now get called. So that means set timeout will get called. Set timeout gets a handler. Here's the handler that says to just resolve whatever we put in. And so what happens now? Nothing happens, right? We come back to where Node is willing to read the next thing. If we type fast enough, then something happens before the set timeout triggers. but maybe it doesn't. Maybe the set timer triggers before I manage to type anything else in here. Then at that point, this resolve will get called. And that means that the promise will, so I guess you have a point there that maybe that's a good way of thinking about it. So the promise then does hang on to the what. And so at this point, when we call then, it can immediately invoke the handler on it. So maybe I should be more uplifting and say, yeah, kind of. The promise does save the result. Absolutely. That's like, normally we don't think about the promise saving anything because it just invokes the handler. So there was, like I said, there was this other question. What if you want to invoke two handlers on it? And you could. So let me just show this. So let me make another promise here with a produce after delay, and I'll make it that it makes it after 10,000, so I have a bit of time to do something with it. And now I could call promise then console log, and I could call that again. And now it gets called twice. So you can have as many handlers as you want. It's not common to do that because after all, I could have just, if this is really what I would have wanted, I could have given it a function that does that twice. Right, and that has the same effect. So instead of calling then twice, you can always, in the one then, you can put the action, both of the actions in there. So there's no true benefit for calling then twice. And you'll see in just a minute on why that really is truly uncommon. And that is that the way that you normally operate on these promises, you chain them together in a very characteristic way. Let me double check here my chat again. All right. So we will call promise.then, and inside there we have a function. That function can return something else. Previously we just had to do something. A console log didn't return anything, but you can have the function return something else. And what you now have is another promise. So the value of promise.then is another promise that promises to eventually give the second result. It's a little abstract, so we'll give an example. And so oftentimes it could be a value, or it could be another promise. So let me give you an example. So I'm having my first promise for this beautiful image here. The only way that I get that image is to call then on promise one. And so what do I want to do when that image arrives? I want to have that image be processed in the way that it says here. Then what I want to do is I want to append it to some element, and then I want to return something else. And in this case, I'm going to return the promise for the second image. So this whole thing now is a promise. It is a promise to give me that second image after having appended the first image. The only way that I can harvest the promise is to call then, and then I'll append the second image. So in this case here, I will have scheduled very carefully that the first image got loaded, and then after that, the second image got loaded. If that's what you want to do, that's how you can do it. We'll soon see a simpler way of doing it. Now, normally, I would not write it in this form. I would kind of write it in this step-by-step fashion, because it's easier to read. I'd say, okay, the first promise here arrives. Oh, sorry, the first promise is made. When it's done, then I want to append the child. This thing is synchronous, so it'll right away be done. I'll get a promise of nothing, because append, I don't think that element append child returns anything, so this will just be a promise of undefined, but it doesn't matter. It's a promise, so it has a then, And I can say, well, when that thing is done, then do something else. And what do I then want to do is I want to invoke this function here that loads the second image. And when that finally is done, then I want to take that image and append it. So here you have a very typical pipeline where you say you first do this, then you do that, then you do that, then you do that. And it's pretty readable. You do it a step at a time. Some of the steps have nothing to do with asynchronous programming. Like this step is synchronous, it just happens in the future. This step here is again asynchronous. So you can even make that a little bit more symmetric, because if you look at the steps here, this phase here where I'm wanting to load the first image, and the one here where I'm wanting to load the second image, they kind of do the same thing. In the second time, I have to call then. And I can make it so that in the first time, I also call then by starting out with an immediately resolved promise. This is a promise that gives me undefined right away. And then I call then, and then, and then, and then. So you have this very symmetric chain where you say, you know, let's first do this step, then do that step, then do that step, then do that step. It's pretty easy to read. And intuitively, it does exactly what you expect. It does the steps one at a time whenever the result of the previous step may be ready. In some cases, it takes a while for the result to be ready. In some cases, the step finishes immediately. So here's now what a promise really, really is. So a promise is a way to compute a value or an error in the future, and an API that makes it easy to compute and to compose what you want to do in the future. So you should think of a promise as, you know, this promise for something in the future, and an API for composing these computations. That's what makes promises powerful, that it makes it really easy to say how you want the future to work out. Now, one bit of caution here, that there's an easy mistake to make here. And that is the following, that if you have to be really careful that the argument of then should be a function. There's nothing in JavaScript per se that checks that, right? Whenever you call a function, you can pass it anything. If you use TypeScript, then you get a compile time check, but with JavaScript, you don't. And so it's perfectly legal to call a promise and then pass it something that's not a function. I've done that here. I've called produce after delay. That is a promise to give me hello after 1,000 milliseconds. Then I call then, and then afterwards, I just pass it a non-function. I pass it a value. And here, the promise people did something really nasty. They could have produced an immediate error, right? They could have checked whether this argument is a function and then immediately failed when it isn't a function. But instead, they just kind of silently ignore it. And so that is really unhappy. Let me demonstrate this here really quickly. Let's see what P is. Here then. Oh, it's hello. What about this goodbye? It's just nowhere. Nothing is ever done with it. There's no error, there's no nothing. And the most common case that people make this error is that they forget this arrow here. So I'll do it with produce after delay. So what I really want to do is I want to first produce a hello, and then I want to produce a goodbye. And so here I accidentally call it like this. It's not a function. And if it's not a function, then we'll silently throw whatever you gave it away. Well, it's a promise now that was never harvested. Or if I omitted here the parentheses and the arrow, then this would also be bad, because the second image here, it would be loaded, but its answer would never be harvested. Okay, so here the question is, what does promise resolve then do that's different from promise.then? And this is an excellent point when to answer that. Let me get like a text editor window here that's big enough for me to type. So the question is about promise resolve. And then and so here I would put now a function. Let's log it. That doesn't, oh, actually I shouldn't, this doesn't make any sense at all, right? Because there's no X. So I would have to put a function here that, what I had before, that gets me an image or something. I'll just call load image. So that's the one thing we want to look at. And the other thing we want to look at is promise.then. Well, I'm not sure. No, that you can't do, right? Because then is not a static function. So you would have to call then on some promise. Well, but we can do it like load image. And so then there would have to be some other action here. And so we'd have to have some other action here. And these two are equivalent, absolutely equivalent. And so the only reason that I used the second form, let me clean this one a little bit up here, is for symmetry. And so you might say it's a little bit longer, but now let's say I load a second image. Then here I would put it like here, and it looks completely symmetrical. Whereas if I do the same thing over here, and now load my URL 2, and it doesn't look symmetrical, right? Then the first and the second one look slightly different. So the only reason I did this was for symmetry. And so if we go back to the form that I had when I said, now they're completely symmetric, these in fact are exactly the same thing. All right. So another important thing is that if you abandon a promise, it delivers no result. So if I call load image, and I don't call then afterwards, the image will be loaded. It's somewhere, but it's the computation is abandoned. So if you have a promise, you should always check in your code, and it is then called on it sometime, and if not, it's definitely wrong. It's definitely a sign of an error then, because there's no point in calling a promise, in making a promise if you have no intent of harvesting its result. So, and here's another food for thought, that if you think about what I've said about composing, I've said what makes these promises powerful is that you can compose them. And really, that's what you're composing is not the promise. What you're composing is these functions. Here is a function that yields a promise. Here is another function that yields a promise. Here is another function that yields a promise. And here is another function that yields a promise. Those are what you can compose. It would have been a better API if that would have been the composable concept, if they would have given that the nice name. And so there are, in other languages, that actually happens, where it's not the promise itself, but it's the function that yields a promise, where that is kind of your basic object. Those functions are the most important part. And that, again, is why I like to start out with just this naked promise, because then I can use then, and it's the functions that are now in center stage. So you should always think of functions that generate a promise. That's the things that you want to do one and then the next and then the next. So I have a little demo here. Let's look at the source code. So here I have the load image function, and here I have exactly the code that you've just seen. I load the first image, then I append it, then I load the second image, and then I append that. And you can see that the code is perfectly legible. This is not complicated code. And it's made possible by the magic of the promises. If you did this with callbacks, it would be a bit of a pain, right? You'd have a callback inside a callback. So the reason people like these promises is they flatten out what would otherwise be nested callbacks into this one after another. And by the way, the images get loaded in order because the second load image only happens after the first one has returned. All right, so now a little exercise for you to see if this is sinking in. So put the answer into not the chat, because that way everyone sees everyone's answers and people will stop as soon as they see the first right answer. So put it in the Q&A instead. And so here I'm making the API, my mini API a little nicer. I have this append image function. It takes a URL. It takes an element. And then it returns load image of URL, and then the action where the image is appended. And now I'm making a few calls. Some of these calls may be right. Some of those calls may be wrong. And I want to know which of those will append these two images, and always in order. So, here I'm just calling the two functions. Here I'm calling the first one and then the second one. Can I even do this? Here I'm calling the first one, then and then there's a function in here. Here I'm using the resolve thing in two different ways. And so these things are all doing subtly different things. And some of them will work and some of them won't work. So if you reflect on the rules that we had before, where I said, what can you pass on to then? What does the argument of then have to be? Think about which of these here will work. So some of them will actually never display the second image. Some of them, or at least one of them, will display there won't be a guarantee that the two images are in order. And one or two of them, I actually can't remember, but I won't tell you. One or two of them will always append the two images in the correct order. So let's see if I can see the Q&A. Yeah, okay, we've gotten a good number of answers here. And also got a bunch of questions in here that I will have to catch up to. So it's a good idea if you use the chat for questions and use the Q&A for these quizzes, so that I don't get too confused. Okay, but we got a lot of answers here, so that's great. And I will go over those questions after I'm done with this thing here. All right, so let's see what the first call does. It calls append image. I get back a promise. Okay, and eventually, what does this append image do? Eventually, it'll actually append the first image. It's guaranteed to do that, right? Because append image, that's what it does. And then I call the second, then I call it again. But of course, there's no guarantee of timing. Right? These both go on, they load an image, they append the image, but in which order, we have no way of knowing. That just happens, whichever image happens to come in first. So this can't do them in order. Now let's look at the second one here. This will append the first image. After the first image has appended, it'll then call this callback here. Except there isn't a callback. Right? The argument of then should be a function, but this thing here isn't a function. So that function will not afterwards be called. So the first image will get appended, and then nothing will get called. Well, what about the second image? It does get loaded because this call here will go forth and load the image and append it. But when that happens, we don't really know. This second image loading will be launched exactly at the same time as the first image loading. Now let's look at C here. C looks good, right? Here we're loading the first image, and then gets a function. That function only gets invoked after the end here, and so then the second one gets loaded. So C is one of the right answers. Now here we're having the things with the resolve. Well, we're rewriting with the resolve in the same way that we've done before. So D must be wrong again, because the argument here is not a function, but it's just a promise. So yes, the images will be loaded, but not necessarily in the right order. E is correct because we first do nothing. Afterwards, the first image gets loaded and appended. Afterwards, the second is loaded and appended. So if you got C and E, pat yourself on the back. Let's get an idea of how many C's and E's I got. I got a good number of C's and E's, so this is working good. All right, so let me just catch up here with some of these here. Is there a difference between using new promise and promise? That's a great question, and absolutely, there's a huge difference between. So if the only time when you would find a new promise would be if you're a library author and you need to produce a promise that your customers, meaning other programmers, would want to consume. So then you would be in this arduous business of saying, okay, I'm going to have to deal with a function that takes a resolve reject. And then that does all sorts of stuff with that. It's pretty unlikely that you will ever do that, because almost everything that you might ever want to do asynchronously, like connecting to a database or fetching something, someone else already has an API for that. So you almost never use new promise. The promise dot, that means that you're going to be invoking a static method that's given by the promise library. There's only a couple that you can use, and the most important ones are resolve and reject. So you could immediately resolve or immediately reject. In that case, you would use promise dot to get one of these this handful of static methods. So if you don't return anything on the resolve of a promise, how do you chain them? You don't. So again, it's not something you have to worry about too much because you're not likely to write a new promise, but nothing will happen is if the executor function never kicks off a process that then later calls resolve. No chaining will happen. Again, it's not something that you need to worry about it because the people who write these promises, they should know what they're doing. So it says, the call to fetch the image will be invoked when then is called. And while there's so many calls, that's a hard question to pin down. And again, I can't overemphasize how complex the order of execution is here. So when I call load image, nothing gets called so far. All I do is I call this constructor. The promise object is made, and inside it holds the executor function. Now I call promise1.then. So now the promise object inside it holds two functions, the executor function and this callback. And now my JavaScript code may be puttering along for quite some time before the main thread hits a pause. You know, that might be because it's executing inside some callback, either of a server-side or a client-side program. And eventually, when my code hits a pause, and then the runtime says, oh, we have all these promise objects, let's start doing something with them. And then the executor function gets called. That executor function starts loading the image. Much, much later, the handler for the XHR will kick in when the image is finally arrived. And then at that point, the resolve handler will be called and the then function will be called. So it's always a good idea to have this in mind, that when you call a code that gives you a promise, or when you call then, at that point, all you're doing is you're setting things up for the future. Nothing is happening right then and there. But then in the future, the right thing will happen. Your task will get kicked off, and when your task is complete, the handler of your task will invoke the right callback. So why does we say that JavaScript is single-threaded when the promise is, when obviously there are other threads going on? Well, the code that you write can only run in one thread. You as the programmer, except there are now some features that let you do these things, but you as the programmer, in a normal JavaScript program, if you don't use something like web workers, you just have one thread. Everything that you do happens on that one thread. So as a JavaScript programmer, what do you normally do? You have a bit of code that kicks something off, but even that is usually in a callback like document on load or on ready state or whatever. And so all your code really is in callbacks. And the JavaScript runtime will ever so often invoke one of your snippets of code, run it to its completion, and then the JavaScript runtime has control again. Of course, the JavaScript runtime will have a bunch of threads for every web request, but that's all managed under the JavaScript runtime. So the JavaScript runtime may have to worry about competing threads and scheduling and all, and race conditions and all of that. But you, the programmer, never worry about this at all. You simply get your tasks serialized in order. They will come in some order, and one gets picked, then another gets picked, and so on. And every time that your code starts, it will run to completion before any of your code starts again. Doesn't mean that some other code isn't running, but your code is one function at a time. And so what's the then function is way below the main. Okay, I'm not sure that I understand that question. So maybe you could rephrase that, and then preferably in the group chat. All right. So where were we? We were at this exercise. Okay, now another exercise because the first one worked so well. So here I have my print after delay. What does it do? Is there's a timeout. When the timeout is expired, then it'll print out in the console whatever value is one after the delay, and it'll also return it so I can use it for chaining. And what I want to know is, for each of these, I want to know how many seconds does it take for the printouts to appear. And if there's more than one printout, I want to know when does the last printout happen. So I'll go through one example where it's kind of easy, and then I'll leave B, C, D, and E for you to ponder in the Q&A, please, not in the chat. So the first one here, let's see what we're doing. Expressions are evaluated inside out, so I have to first worry about this thing here. This thing here will return to me a promise. So it'll instantly print the promise onto console log, and then 1,000 seconds later, then it will print hello when the callback is triggered. So here the answer would be 1,000 because the last printout happens after 1,000 seconds. Okay, so give it a try and give me your estimates for B, C, D, and E, and then we'll go through them. Here we have A. And as I promised, we get the first printout instantly and the second one after a second. Let's see if something in the Q&A. Okay, so this seems to be hard for people because I can't yet see any time estimates. Oh, also, as you're pondering this, let me show you another way that you can run this. If you go to REPL it, just in case you're somewhere on a desert island and you don't have Node running. So here we have, and I'll put this in the group chat. Then you can just paste your code in here as well. All right, so someone said, why is JavaScript designed as single-threaded? Wouldn't it be better if we could use multiple threads? And the answer is because JavaScript is your friend. It is so much easier to write your programming logic if you don't have to worry about threading. So think about what you normally do with JavaScript. I would imagine most of you will either write a user interface or you write code on the server. And in a user interface, your entire user interface is a collection of tiny functions. Someone presses a button or some other event happens in the UI. You need to react to that. And there's nothing to be gained by using concurrency there because your functions, they do something quickly and then they're done. On the server, you react to incoming requests. And again, in theory, you handle the requests in a jiffy and the result gets transported out. And yeah, there is concurrency. Multiple requests can happen at the same time. But whenever you program one request. And that one request, you don't really need concurrency. So if you do need concurrency for something, nowadays there are ways to doing it, but most of the time in your bread and butter JavaScript programming, you don't need concurrency. And it is a huge advantage that you don't need to worry about thread safety. It would be genuinely difficult if you had to organize your code in such a way that, say, 2 button click handlers could run in parallel. Your button click handler will do something. It'll disassemble some part of the DOM tree and put something somewhere. And if concurrently someone else could also mess with the DOM tree, then bad things could really happen. So cherish the fact that the programming model in JavaScript is that there is a single thread in which your program
What is recursion?
It greatly simplifies your life. All right, so let's see. Now we're getting here a bunch of great answers. So let's go through some of these here. So the first one here is going to print 1,000, hello in 1,000 milliseconds. That's what this thing does. And then it's going to print hello one more time, instantly. So it's going to be over in 1,000 milliseconds in a bit. This one here prints hello in 1,000 milliseconds. And after that has been printed, it goes on Ooh, no, because this is not a function. The argument of then needs to be a function. This is not a function. So it is going, this call here and this call here happen concurrently. And after 2,000 milliseconds, it's all over, right? After 1,000 milliseconds, the hello will be printed. After 2,000 milliseconds, the goodbye will have been printed, and nothing exciting happens with the thing. The one here does what one was hoping for. It really, after 1,000 milliseconds, prints hello. And then after 2,000 milliseconds later, it'll print goodbye. So that'll be 3,000 milliseconds. So far we had 1,000, 2,000, 3,000. Now, what about this one here? Here we're doing something that's a little different. We're chaining two things after P1. You can do that. And so those will then happen concurrently. So after 1,000 milliseconds, the first one will happen. And then after about 1,000 milliseconds, those other two will also have happened. So it's not very common to do this, but you can. In this case, you can't write your pipeline as neatly, right? You have to actually capture one of the promises in a variable so that you can execute then on it twice. But it's perfectly legitimate. These two happen concurrently, and after 2,000 seconds, it's all over. So the right answer would have been 1,000, 2,000, 3,000, 1,000. All right. Now, when you think about then is a sequence of actions. And you can think of it as the analog of statement sequences in a programming language. A statement, semicolon, statement, semicolon, statement. And so then it's kind of the same thing. It's a method. It's a method on promises. And so what if you want more complicated control flow than just statement sequences? Then it's a little ugly. Then you need to build up promise objects. So let me give you an example. What if you want to do an if or else? So like in my example, if I is greater than 4, I don't have enough. I only have 4 of these images. So I want to have a promise that is either a broken image or it is one of these 4. Then I can do it like this with a question mark colon. So I can't use if else because promises, they're not statements. They're not something that I can execute with an if else. Promises are objects. So I have to operate on the level of values. So the question mark colon will work. It'll give me either this promise or that promise. And then on this thing, I can call then and say, let's harvest that image. So I either get the broken image or get one of these loaded images. And in both of the branches of the question mark colon, I have a promise. Here's a promise out of promise.resolve, the static method. Here's one that comes out of load image. So P is a promise. I can call then on it and say what I want to do with harvesting. So this is how you would do an if else with promises. A loop is super unpleasant. So with a loop, you have to manually build up a chain of actions. So here I want to load n images. I start out with an empty promise because it simplifies my logic. And in the loop, I say, well, I take my previously built up promise object and add another then to it, or in this case, 2 thens. So I say, well, let's load the thing, and then let's display it. And I add these 2 handlers to my P. So I build up a pretty complicated P that now has 2n thens on it. It has, and so really I'm building up a chain of 2n promise objects. And that's what you would have to do if you want to encode a complex action like this. So here we'll have this, and the output is not interesting. What's interesting is the code. So here we have exactly this loop that you've just seen. And you can see it does the right thing, but it's not pretty to look at. So as a quick exercise to you over the break is, can you write a loop that prints 1 to 3 to 10 with 1 second between each number? Of course, using our function that produces something, prints something after a delay. So, just do it in Replit, paste this thing in there, or if you have Node, do it in Node, it doesn't matter. And then go forth and fill in the details of this loop. All right, so let's have a 5-minute break. If you have nothing better to do in that break, go and finish it, and we'll go over it after we're done with it. So let me push the break thing here. So I'll be back at 5:30. So I've pasted this thing here into Replit just to show off Replit. And so now I need to build up this promise object. So I need to say p equals p.then on here. What do I put inside the then? The important thing is what goes inside the then is a function. So I should immediately type in this function here. In my case here, I'm not sending any parameters from one step to the next, so the function takes no argument. And then what's the function? Well, I guess we're going to call produce after delay again. And so it's every 1,000 milliseconds. And we're going to produce the value I. Okay, so that didn't work. Let's see if, oh, that's because I didn't print anything. So I guess I do need to do something. Namely, I also need to print what this thing produces. So that would be another thing. And now you can see that every second, one of these values gets produced and then printed, and the next one gets produced and then printed. But you know, it's an unpleasant way of programming it. See what are we doing with the chat? All right. So another example of an API that uses promises is the fetch API that you have in every modern browser. So you can say fetch, and you give it a URL, and then you get a result object, and out of that result object you can fish out various things. So here I'm calling, I want to get the result as JSON, and even that call is asynchronous because you might have some humongous JSON to parse. And so I have to give a second function here that says, take that result, get the JSON out of this, and then I get text and I can print it to console log. So when I do this here, then I get an object out. Let me show this first in the browser console here. So then I'll show where the dog actually comes. So fetch, then I'm not seeing this. Oh yeah. I'm sorry. I'm just being dumb. So so this is the promise. That's the output of this expression here, and then eventually the message was decoded, and it is this object here. It has as its message another URL, and that's the URL of some dog. When I click on it, here it is. And so what this little program does is it does those two steps as well. It does the first fetch, and then it loads the image. So let's have a quick look at the source code of it. So we're calling fetch. We're getting back some JSON. We're decoding this JSON here into an object. Then here I have my object. The dot message is the URL of the image that I want to load. Then I call load image on that. The image comes back, and then I stuff the image into some element. So you can see in this straightforward case, the programming model is perfectly nice. I don't really have to understand much about promises. I didn't have to write any functions that make them. Now I use fetch here, and I use this load image here, some library functions that I have. And then I call then, and I'm happy. You can do this. So now what about the not so happy case when something goes wrong? And there are two ways of doing it. The first one is when you call then, you can give the positive handler and the negative handler. But that's actually kind of tedious because it branches out your control flow. So there's a better way of doing that by using catch, as we'll see in the next slide. And well, catch is just always better. I'll just show you how to do that. So when you have a promise, you can call catch on it, and then it gives you some and then you have the chance of interposing some handler, and you get a new promise, but we don't really care. So let me show you how you normally do it. So what we normally do is we call then, and at the very end, we put a catch handler. And this, now let's imagine that, say, the second load here goes awry, that image just doesn't exist. In this case, this then here is going to produce a failed promise. The next then is going to do nothing on the failed promise. It's just going to it's just going to give it back. And then this catch here will take the failed promise, will take the error object, and in this case, just display it. So this is the most common way of handling a failure in a chain, that you have the entire chain do its happy thing. And if anything goes wrong anywhere, then the catch at the end will take it. So the then has been carefully designed so that it simply propagates failure, and that it's willing to accept failure and then propagate it to the next level. The other thing you can do with the catch is you can put a catch somewhere in the middle and then have it recover the situation. So here I can load an image, and if that image failed, then I can return a promise for something else, like here a broken image, and then I can then go on as normal. So in this case, I have a catch in the middle of the chain, and it detects an error and provides a recovery mechanism. If, on the other hand, this then here succeeded, then the catch over here does nothing. My chain simply goes on in the positive path. So this mixture of thens and catches gives you a pretty decent way of doing error handling. And so here we have an example where the first call succeeded, the second one didn't. And if we look at the code, it's just what you've just seen. I'm trying to load a bunch of images. This 1-5 doesn't exist. And so that means that none of the other thens then happen, but instead I get an error message that is dependent here as a text node. There's also finally, and so that gets called just like finally normally in exception handling when a promise either was successful or it was not. And so you might use that like for closing a database connection. The final takes a function. The function has no argument. You have no way of knowing whether the previous promise was successful or not. You just do your cleanup. And these are always chains. So after the final, you can put more things. So it was invoked on a promise, which really is from this chain. And it just gives the same promise back, so you can keep on chaining. We talked about promise resolve, and so you use it to kick off some chain of tasks. So for example, I could have kicked off my chain instead of with the empty promise with one that gives me the first URL, and then I could have used that as a parameter here. So that's sometimes done to make a chain more symmetric if the next step happens to be the same way. It also sometimes happens that you have a function that under certain circumstances you have the answer right away. Under other circumstances, you only have the answer through a promise that comes later, and you would like to have a uniform return type. Now in JavaScript, of course, you don't have to have it, but it's still nicer. If you have TypeScript, you do need a uniform return type. In that case, in the case that you happen to be able to get the answer immediately, you would want to wrap it into a promise. So that way, and also it sometimes happens that someone gives you a thing and you don't quite know, is it a value or is it a promise? And you can then wrap it in resolve, and then a promise stays a promise and a value is turned into it. There's also a promise.reject that you can use to make a promise that fails immediately. Like here I have an example of that in load image. If the URL is undefined, then I return an immediate failure here. And again, what I want to do is I want to have a uniform return type. So this is a promise. Over here, I have a promise. Now, what if I want to execute promises together? I can use promise.all, and I have to give it an iterable of promises, usually an array of promises. And then, again, I get a promise that's resolved when all the promises are resolved. Now, there's all of these tasks in there, and they are not getting executed in parallel, but they get executed in a single thread. All the code that you have in there gets executed in a single thread. Of course, there may be code in there that fetches stuff, and the runtime may do that in parallel. So the combined promises promise, when it finally is resolved, what you get is all the results in the same order. And you can actually toss in a few non-promises into the array, and they just come right back. If any of the promises get rejected, if any of the tasks have failed, your entire thing fails. There is a second method that is called all settled, where you can look at each of the results individually, which is probably what you want in many cases, because that behavior of that global failure is probably not what you want. So we're not going to talk about all settled today. I just toss it in here in the slides. This promise.all will make sure that all of the results are harvested. And that's normally what you want. Like you might want to get a whole bunch of images. If on the other hand, you do some search, then you might be happy if any one of your tasks has found a result. Then you use this thing called race that will go through all of the promises that you give it here. And as soon as one of them has finished, then that's the result. If you toss in some non-promises in here for some reason, then of course that's going to finish right away, and that's going to be a result. And just as random weirdness, if you give it nothing, then it never settles. And it is possible that a rejected promise wins the race. And so if you don't want that, then you use yet another method called promise any. All settled and any are newer functions. They're probably the more useful ones, quite frankly. So let's just have a quick demo with that. So the first 4 images here are done by all. The last one is done by race. Keep that in mind as we'll look into source. So here, I'm taking the numbers 1, 2, 3, 4, and I'm mapping them to an array of promises. Each of the promises is a load image, and so it loads the image 1, 1, 1, 2, 1, 3, and 1, 4. So now I have an array of promises. I feed that array of promises to promise.all, And now I have a promise for an array of 4 images. On that promises I call then. And what am I now getting? This images, it's an array of 4 images. And now I walk through the images and append them. I don't know in which order these 4 promises were settled. But I do know that they're packed into this array in the order in which they appeared. So I'm guaranteed to get them in the correct order. Now here I'm doing the same thing with race. So all I'm doing is I'm replacing all with race. I'm having here my 4 promises. One of them will be done, and the one that's done is a single image, now not an array, and I append it. So in theory, if I run this here multiple times, the last one might change. And as you see, it just did. All right, let's see how we're doing on chat. So does the then chain guarantee that they will be executed in that order? Oh, absolutely. If you say then, and then another then, and then another then, that the callbacks, so the first then will produce some other result, either a value or a promise, and the second then will then operate on that other result. So yes, so the then is definitely sequential. All right, so now we've talked about these promises and we've pushed them as far along as one can. And so promises are better than callbacks. The then and catch mechanisms give you a way of specifying the actions that you want in with a pretty reasonable, easy to write, easy to read API. But still, they're not perfect. Like you've seen when we had branches or loops, it got outright ugly. And so they're really just the first step. The second step is these async functions. And so async functions operate on, the async operators operate on promises. So there's a thing called await, and it's given a promise, and it waits for it, and gives its value. But didn't I just say that you can't wait in JavaScript? And you really can't, except in a function that's tagged with async. So let's look at this puppy here. So I have a function append image. It calls await on a promise. The argument of await is always a promise. We get the answer of what's inside this promise. Yeah, previously I said you can't do this. When you have a promise, all you can do is call then. I specifically said the only thing you can do on a promise is call then to get its value. But it turns out that there's also this await operator. And yes, it will actually, well, it will not actually, but it will seem to wait. Now I get this result, and then I append. Now this function here can't really be a regular JavaScript function. A regular JavaScript function cannot possibly spend any time waiting. There's only a single thread. And in fact, it doesn't. We'll see in a minute what it does. But you can write code like that as long as you tag that code with async. If you omit the async, you're going to get a compile time error that says you can't call await outside an async function. Now what happens under the hood is that this append image function is actually transformed into a regular function that uses regular old promises and then. So here where it's written await, the actual code that is run is the classic code with the then. In many cases, you don't really have to think about this. You can perfectly well have the intuition that await does the right thing. That it simply kind of waits around, and when the value is available, then your stream of actions here putters on. But there are situations where it's unintuitive what happens, and you kind of have to be able to translate it into promises in the back of your mind, which is why I introduced promises first. It would be nice if one didn't have to do this, but it's just not the case. So it's a bit of a leaky abstraction. So here is code that loads 2 images using await, and you'll be pleasantly surprised in just a minute how simple it is. So here I'm picking the element, and now I'm calling append child, And I would like to call it with load image because load image, after all, is going to give me this image, right? But it doesn't actually give me the image. It gives me the promise of an image. And so I call await. That magically turns the promise into the real thing, seemingly waiting for it. And so I can write this code just in a completely straightforward linear fashion. Behind the scenes, this thing gets turned into a mess of things. And that's usually a question right around this time, so. So here we have this thing here, the same code that you've just seen with multiple awaits. Before I had it chained even more, where I put the await right in here. It's an expression, so I can put it right in here. But here I've detangled a little bit because I wanted to show the transformation. So this thing then gets transformed into a load image URL 1 dot then, and then inside the dot, and then there is a second dot then. Now I can put an await in a loop. So here I have an array of URLs, and so for all of those, there's a const missing here. For all of those URLs, I call load image, and then I call await to turn the promise into an actual thing, and then I append the image. So all of the promises seem to have disappeared. I can write my regular old programming logic, and it just works. What happens behind my back is, of course, that this function here is rewritten into a non-async function, into a regular old function that builds up in this loop a chain of promises. So here is again the code. And so this one here loads a whole bunch of images. Let's look at the source real quick. And so all it does is it has two nested loops. It then appends the elements that are awaited from calling this function here with where both the month and the card index vary. To write this code with explicit promises can, of course, be done. Now, you would have to build this thing up here, but it is super unintuitive. Whereas here with the await, it's nice and simple and clear. You can see right away what it does. It's not so clear how the timing works. That's where understanding the promises really comes in handy. But in terms of just writing the right program logic, it's much better. So in practice, you should generally use await. So just to see if you can do this, remember that previous replit exercise, which we had here? Try writing this with await. So in this case, we have to put it into a function because we need to tag that function as async. So we'll write a function count. And so we want to put in a loop. And so we want to call produce after delay, and then we want to print the value. So let's naively do this. So we'll say let x equals produce after delay. And then we'll say console.log x. Take this thing out. And I'll call count. And of course, that didn't do me any good whatsoever, because all I've done is I've looped through this loop and I've produced 10 promises. So, of course, what I wanted to do is I wanted to wait for the result of each of these. So I put in a wait, and I'll run it. That didn't work out because a wait is only valid in async functions. So we'll tag this as async. And now it prints 1 to 10, as we wanted to. And why does it also print promise pending? Hold that thought. Okay, let's see what we're doing with questions. Okay, how to implement catch in this? I'm not sure I understand that question, so maybe you could rephrase that. Say, I mean, catch is a method of the promise class, so you don't implement it. You know, the normal rule is you put a catch at the end of a chain of promises, so that you can react to what, if anything, went wrong in any of the steps. Or you can put it in the middle and fix something like we see. All right. So yeah, so we've done this, and yeah, isn't this a lot nicer than the first time? Of course, it's a lot nicer, right? This is the kind of code that you really want to write. You just have to know that in the back, this code does not actually wait. And you can see that it doesn't actually wait, because you have called count, and it came back instantly, namely with a promise. Every async function does return a promise. All right, so syntax, you can tag regular functions, the functions with async. If you use an arrow function, you tag it kind of the same way. You put async in front of it. If you have a method in an object literal, you can put an async in there. If you have a method in a class, you can put an async in front of it. And in all cases, you have now turned the function or the method into an async, which now means that it's been rewritten to produce promises. Now, as I just said, an async function always returns a promise. So here I've written a function that returns an image URL for some random dog. So I call this random dog service here. It gives me back some JSON. With the fetch API, I have to again call await to parse the JSON, because it's only a promise for a JSON. I now have my object. I call .message. Now that is a string. It's just a plain old string. And now I'm returning it. And so it appears that get dog image URL, what it does is it returns a string for a random dog. Now it does not actually do that. It returns a promise for such a string. So let me actually put this in the browser. Here we have a function, and now if I call get dog image URL, you can see it returns a promise. So how do I know what's in the promise? Well, I can call then, right? That's how you can also always find out. Console log. And just a second later, here I get my random image. Now, let me do it again. And I'll get a different dog image. But it's essential that you call then, even though it appears that this function returns a string, it does not return a string. It returns a promise for a string. Every time that you have an async function, then you write the code as if you were working with values. This thing gives a promise, await turns it into a value. This thing is a promise, await turns it into a value. And then here, this thing is a value, And now coming out of the function, it's turned back into a promise. So await turns a promise into a value, and an async function, a return in an async function turns a value back into a promise. Yeah, so you can consume it with good old then, or you can consume it with await, right? I could take this get dog image URL. It gives me a promise for a string. I call await, and now I get an actual string. I can only do that in an async function, of course, because if I try to call await in a non-async context, I would get a syntax error. If inside an async function, I return something that's not a promise, it gets automatically wrapped into a promise. So in this case here, it returns a promise for null that's instantly resolved. Now here let's look at the pathway of this code here. So I call fetch. Fetch is a promise for a result. I call await, that gives me an actual fetch result. Then again, I get the JSON here by calling await again. It's now a Java object. And now I call load image on it. Well, what does load image give me? It returns a promise. And that's perfectly fine. The promise doesn't get wrapped into another promise. I just get the promise. I still prefer to call await here. And the reason is, it's homogeneous. I like it so that when I write an async function, that I never return promises, but instead I rely on that conversion. And so syntactically, I find it cleaner by saying let's turn everything into objects, and only at the end they become promises again. But other people don't care, and they say they just return the promise because after all, that's what an async function does. So just think about what you might prefer. See how we're doing in questions. Okay, I'm going to ask you about the try blocks, and hold that thought, because when we come to async and await, there's an interesting try block story. Yeah. So my feel is that inside an async function, I want to work with values. That's the whole advantage of using async. So every time that I have any promise inside, I instantly call await and turn it into a value. Yeah. So exceptions. What if something goes wrong? And there, things actually work super nicely. So let's first of all talk about throwing exceptions before we catch them. So here I'm writing an async function, and I can either get a dog image or a cat image. And so that's some way that I'm doing this, doesn't matter which. And if the argument here, the type is neither dog nor cat, then I'm going to throw an exception. So I call throw here. So I can call throw inside an async function just like I would do it with a regular function. When I call throw, that gets turned into a rejected promise. Every async function returns a promise, and if the async function got terminated with a throw, then I get the rejection that's inside the throw. So as the programmer, I don't worry about this this complexity. I just call throw the way that I would always do, and the right thing happens. And the right thing also happens with try catch. So this is much simpler than the catch thing with thens. You simply write the try catch that you have always written, and it does the right thing. So here I'm calling await load image. When this promise fails, when it's rejected, then of course there is some rejected promise and some complicated chain, but I don't have to worry about building up that chain. Instead, the compiler does this for me, and when that exception happens, this code here gets executed. So this gets rewritten into the correct then catch chain. Now, just as in regular programming, you don't have to put a try catch around every await. You can put a bunch of code inside and only have the try with multiple awaits and have the try catch where you want it, whichever is the best spot for you to deal with the try catch. So let's look at this example here. So this example here loads a dog and a cat image, and then we'll see a sign of failure here. So let's see how that's done. So we have an array here of 3 strings, dog, cat, and unicorn. And so for each of them, I have a try catch where I want to append the child that I got by calling await on load image. And here I have another await, by the way, where I get the URL. So await is an operator, so you can nest those as much as you like. And so, what I really want to do is I want to get the URL, I want to feed it to load image, and then I want to append the image. And unfortunately, this is an asynchronous call, this is an asynchronous call, so I can just stick the awaits in here, and the right thing will happen. If anything goes wrong, in either this await or in that await, then the catch kicks in, and I instead put in the broken image thing. See. So that should kind of explain what you really want to do in your code to deal with exceptions. You want to use await, and you want to use the regular old try catch. Behind your back, this will be rewritten into the appropriate then catch sequence of statements on promises, but you don't have to write it. Okay, so here we have another little quiz here. What I want to know is, what do these functions return? And some of these, well, I'm just going to answer I'm going to ask the question like that, right? What do they return? Let's look at A, and then you can do the rest. So what does A return? We're calling produce after the delay math random, so it returns a random number, presumably after some delay. Now, here we're calling await. So after 1,000 seconds, we get some random number, 0.42. And so the await means, we're presumably waiting for that, and then it returns the random number, right? Except, of course, it doesn't, because it's an async function. Every async function returns a promise. So this thing here returns a promise for a random number. Now, what about B? There's no await here. What about C? There's no await here either. What about D? Is D even legal? Can you throw this exception? Yeah, you can, right? You can throw an exception, and, well, what does it return? All right, so let's, why don't you ponder that and put in a couple answers into the Q&A. Let me catch up with the chat. I think we've beaten the try block here. Yeah. What about await before mastered random? That's okay. That's another excellent question. So let me let's play this through. Let's say we put in await here. In this case here, the math.random, since it's not a promise, if you call await on a non-promise, you get the thing right back. You get it. What you actually would get, well, actually what you would get is you would get an instantly settled promise. And now this is going to be confusing, because what happens if you put it into produce after delay? So let's actually play with this in here. So I would put an await here. And so it does seem to work. So, but it's kind of confusing what really does happen. In that this thing here really is a promise. That promise gets returned, and then it gets unwound by the await over here. This is not something you would want to do. In this case, you don't want to unnecessarily wrap a non-promise into await. All right, let's see if we get anything in the Q&A. And so, I've got a bunch of more questions in here. So does a wait block? You should know the answer to this. So does await actually block? And the answer is a definite no. Await does not actually block. What await does is an instruction to the compiler to rewrite your code into a then. So anytime that you say await, it gets rewritten into, well, it mostly gets rewritten into a then. So let's look at a more characteristic example where we don't have a return await. Let's look at this example. So here I have a call that gives me a promise, and then I call await, and it does not block. There's no blocking. One can't block in JavaScript. No blocking is ever possible. What happens instead is that the code that you so lovingly write gets rewritten so that there's a get animal image URL, and then there's a dot then with some function that contains the rest of your program. So this all of the stuff that's here gets kind of turned inside out into a function, and that function gets put inside of that. So await does not block. Await simply rearranges for the rest of the computation to happen when the promise is set. When you have nested awaits, then you get a chain of multiple thens. And the same thing is true for try catch in an async function. There's no actual try catching. Instead, it gets rewritten into calling the catch method on the promise. This rewriting can get complicated. There's no question about it. So someone asked why my menu's in Italian. Well, my daughters are just learning Italian, so I figured I should learn it too. And yes, that's why I set my menus, because it is amazing how much of a foreign language you can learn by just struggling with the menus in it. So yeah, I highly recommend that if you need to learn something. All right, so let's go through these really quite subtle things here. So over here, we're returning a promise. And yeah, so that promise just gets returned. An async function returns a promise. And so the promise in this case wasn't awaited. It doesn't get wrapped, double wrapped. It just returns this promise. Here we're returning what seems to be an answer. Well, it actually is a promise. So if I write this function here, put it here. Now I call the answer. I copied A. Then I get a promise for 42, but I do get a promise. So back here, I'm outside of the world of asyncs, so I have a promise in my hand. Every async function returns a promise. So here, this thing here, what does it return? Well, it must return a promise. Every async function returns a promise. It is a promise that half the time is fulfilled after some delay, or that instantly is rejected, but it is a promise. So if I call this, I call random after delay 1000. What I get is a promise. The fact that the promise is pending tells me that probably was good. And here I get a rejected promise, and Node is super unhappy when you get a rejected promise outside the async world. All right, so that brings me up to the next topic here. So in an async function, life is simple. Life is beautiful. You're inside the world of async. There is a promise that's not settled immediately. You just call await, and you get the illusion of just blocking for waiting. You don't have to mess around with .then, with .catch. You don't have to turn your program logic into little bits of functions that you feed to .then and .catch. You just use regular control flows that you use to statements, loops, try catch. The logic looks totally normal. So async is, in the lingo of the Matrix movie, it's the blue pill, the illusion of simplicity. But so why don't we just make all our functions async? Well, as soon as you start using async, then that function can only be used in other async functions. There's some functions that really can't be async, like when you look at the callbacks for map and filter. Those are regular functions. They're not async functions. So you kind of lose the ability to use those tools. And so what often then happens actually is that your API splits into these two pieces, into the async part and the regular parts. And sometimes one has to duplicate with both the same functionality in both parts, which is not so great. So that's just the way it is. And that's why not all programming languages love this concept of async. For example, in Java, it was seriously considered to do the same thing because callback hell exists in Java just the same. But there's now a newer effort working out where instead of doing async and await, they're making threads so that blocking gets incredibly cheap and where no one has to be afraid of blocking anymore. So that's what's called Project Loon. But that's Java. In JavaScript, what we have is async and await, and it is good. It is just not perfect. All right, a couple of more things that you have to pay attention when awaiting. Awaiting looks so nice. I have two images that I want to load. I load the first one, I load the second one. Each of them is a promise. So I have to unpromise the thing by calling await. I get the actual image object. The trouble is that this is actually loading these two images one after another. Maybe I want that, then it's fine, but maybe I don't. What if I want to load them in parallel? Because after all, there's no good sense in having one after the other. I want to append them one after the other, but I want them to be loaded concurrently. And so can I do this? Can I kind of put them into an array like this? And here I use this destructuring. And that doesn't do me any good at all because this call here and this call is then translated into two calls to then, and they still happen sequentially. Not so easy to see, right? But I guess one way you can imagine is you can imagine that an expression is executed left to right. And so this thing happens first, and then it doesn't actually block, but it acts as if it did. And then the second one here would come only after the first one is available. Instead, what you want to do is you want to take these two promises that you get from load image and feed them to promise.all. Good old promise.all that we've seen before. Promise.all takes an array of promises and executes them together. And then you call await on the result. The result is a promise for an array after await. It's just an array. And so here, the syntax is fine. You want an array of two images. You have here an array of two promises. But it's just, now you can't say, oh, I'm not going to even worry about promises. One almost had the illusion with regular old await that promises are some detail that sinks into the background. You can just call await on it and undo it. But if you have more than one, then you have to take them as promises, pack them into an array, call a function in the promise API, then you get a promise back, and so then you call await. So you do have to know something about promises to do this kind of stuff. So this is bugging the JavaScript people enough that there is a proposed syntax that we may get in a year or two that works like this, where you say await.all, and that's kind of like a special form for await that you feed this array here. And it's still a little icky. You still have this array in the middle, but that's probably what we're going to get. So that's why the async await stuff is a bit of a leaky abstraction. It makes promises look nice, but at the edges, it really helps to understand promises to use it correctly. So just a little demo here so we can see the code. So here again, I have my 1, 2, 3, 4. I map them into an array of URLs. Then I pass this array of URLs to this helper function here. And here I have an array of strings. I turn that into an array of promises, again with map. Now I have to know this is an array of promises. Then I feed it to promise.all. And that gives me a promise for an array of results. And I have to call await again. It's simple enough. But you really do have to understand what are each of these ingredients. This is an array of strings. Now I have an array of promises. Promise.all turns that into a new promise, which is an array of images. And by calling await, I unpromisify that thing. So now I'm back into the world of objects, not promises. See how we're doing in questions? So can you have async arrow functions? Absolutely, you can have async arrow functions. So I've used the functions here mostly because I don't know you. And I know that someone who doesn't use arrow functions a lot may be more familiar with the function syntax. Personally, I always use arrow functions. I never use functions. And so you just put async right in front of it. Like here, you have I would put async here if I wanted. Well, not in this case, but that's where it goes. What about if you don't want to use delay? That's never a choice, right? It's not that I wanted the delay when loading an image, but it doesn't come instantaneously if I do something async. The only reason that I did this produce after delay function is so that we can experiment a little bit. It's not a realistic function. I mean, I don't want 42 after the delay. I want something real, something from the database or something from some REST service, and those things always come after a delay. All right, so when do you want to use async and await? So generally, the answer is you want to use them. There's a few cases when you can't. So if you are the API programmer who has an existing API that uses callbacks, something that you got from Node or from some database API or something, and now you want to wrap this into promises, then you need to know how to use promises. So async await only help with existing promises. Now, if you call a function that returns a promise, such as fetch, for example, right? Fetch returns a promise, it's been given to you. You have two choices. You can use the promise API and use then and catch, or you can use await. If you use await, that forces the calling function to be async. Well, how about its caller? So let's have a look at this here. So here I'm calling, let's say this is fetch, right? So G calls fetch, and it gets the result that's being fetched. And now this is an async function. And now I'm calling G here inside another function H. Does H have to be async? Well, it depends. If this function H doesn't call await, then no. But if H also calls await, because this is after all a promise, right? It's the return value of an async function. Every async function returns a promise. So G parentheses is a promise. If H wants to do something with that promise, then it probably does use await, and it also needs to be async. So in that case, you would use it. But let's say that H is perfectly fine to return promises, then no, you don't need to declare it as async. Now, it still is a good idea, I think, because when you return a promise, every async function is one that returns a promise. So it's a very clear indication that this is a promise producing function. And if all of your world is async, then why not? So also sometimes you have these functions that return a mixture, sometimes a promise, sometimes a value. And it's actually kind of nice to have a homogeneous return type. In this case, async does it for you. It all turns all the non-promises into promises. So in general, the answer is once you have a wait somewhere, that turns into async. Its callers probably will also be async, but they don't strictly have to be. So the reason that I've belabored this promises thing for like an hour and a half is that if you don't know what promise is, then confusing things can happen. And so when I first learned this, I made the mistake of looking at a lot of blogs, and those blogs can be seriously confusing. That's why I ended up writing a book, because it turned out to be less time wasting to write the book than it was to learn it through blog. So here's a question that I've modified from one of them. So I have this function here. It gets an array of URLs. This is this thing that returns a promise. I call then. Will the images be added in order? And so the only way to answer that question is to really decode in slow motion what goes on here. So I have this promise. It's an object. It's just a JavaScript object. It has a handler that says when the promise gets fulfilled, does this. So what this loop does is it, in rapid succession, generates 4 objects, 4 promise objects. Pretty soon, the executor functions of these promise objects will get kicked off in some order. I don't know in which order. And they might even get kicked off in the order in which they were constructed. So now in the background, 4 images get fetched. Eventually, 4 callbacks gets called when those images are ready in some completely random order. I have no way of guaranteeing that. And then these 4 pieces of code here will get executed. So no, they don't get added in order. So when you have promises, it's pretty straightforward to reason about them, because a promise is an object. It's an object with a bunch of functions attached in its guts, and those functions get called later, and you can pretty much figure out when that happens. And so whenever you look at some messy piece of code, there's a few questions that are good to ask. You know, whether what's returned is a value or a promise. And then when that value gets, when are you going to get the value? Do you get it right away? Do you get it when some function is called? Or when the promise has settled? So those are just some general questions to ask. I'll go through some examples. Now, let's rewrite this thing with async. So someone has written this following code. There's a wait in here, so it has to be an async function. Now, you might say, why would anyone write code like this? The first thing I would look at is the argument of a wait, is it a promise? And here the answer is no. It's the return value of append.append child. Why do people write code like this? Because they want to achieve something, and they randomly sprinkle a wait somewhere. They really do, particularly in blogs. It's amazing. So in this case here, that's not even going to work. Well, it is. It's going to do something, but it's not going to do the right thing. But it fails my mental syntax check. Like I just said, a wait that has as an argument something that's not a promise. It's only my mental check. It'll compile because JavaScript doesn't care. So I don't even want to figure out what this does. The other thing that's really bad here is look at what append child is called with. Append child is not called with an image. It's called with a promise of an image. I don't even know what the DOM will do in this case. Surely nothing good. So let's put the await in here. Now syntactically, we're good. Load image is a promise for an image. Await turns it into an image. Will they get appended in order. And it's hard to reason about that because, you know, a wait doesn't really wait. It produces something. And so it's not so clear to us what this transformation is. And so what you have to keep in mind is that whenever you see an await, then something came before, and then you have await somewhere, and there's some promise, and then something comes after. And so you have to mentally see how the function gets transformed. It gets transformed into this promise, and then the rest of the function. So here, the rest of the function was a loop. What does it mean, the rest of the function? It'll do the right thing, but I find it easier to understand what it does by just assuming that the loop just had 2 iterations. And in that case, you can see that what it really will do is it'll call a load image, then there'll be a then, and then append child. Then there'll be another load image and another then. And so it really will build this thing up. With a loop, it'll build it up inside a loop. But it is kind of easier to see. And now you can clearly see that the images will be appended in order, and that the first one comes to conclusion before the second one is even attempted. So generally, anything after an await starts after that promise has settled. So in this case here, with it, where we have an array of 2 awaits, this await here is going to settle before this argument of the second await is ever launched. So the intuition is kind of the correct one that, about the temporal order. So let's try this, and that's probably pretty much the last thing we're going to do today as an exercise. Here I have my produce after delay that you're now heartily sick of, but it is good for these examples. So what do you think this thing is? Am I giving an answer? Just think about it for a minute. What's this going to print? Here, just put it in the chat or somewhere. Will I be discussing about observables? I will not be discussing about observables today. That would be a good topic for a more advanced talk. So what's this going to print? So like I said, the first thing one should always do is a syntax check. What does produce after delay produce? It's a promise. A promise is an object. So I have an object and a plus and another object. What does it even mean to add 2 objects together? Well, it's JavaScript, it's going to mean something, right? So let's just try this. And of course, the answer is object promise bracket object promise, right? That's what plus does, is it concatenates the stringified form of the object, and toString just returns object promise. So that was clearly useless. And you can see that the syntax check tells you right away, this thing is a promise object. What about this? Now here, the syntax check is legitimate. Right? It says this thing is a promise for a number, and await gives you the number. Promise for a number, and the await gives you a number, so you're adding number plus number. So surely this will print a number. When will it print the number? Either after 1,000 milliseconds or after 2,000. The question is, will this come to conclusion before this one starts, or do they run? Do the 2 timers run concurrently? And the answer is that this thing comes to conclusion. We talked about that earlier, that when you have an await, that you know that before anything happens in the future, this thing will have settled. So if we do this here, then it should take us 2 seconds. Oh, because I have a syntax error somewhere. have to put these in parentheses. Yeah, so there's actually a typo in the slide. The parentheses are necessary. And so 2 seconds seem shorter than this. Okay, we'll worry about that later. So here I'm producing an array, but the answer is going to have to be the same thing. Right? It produces the array. It first does this thing, and then it does this thing. Yeah, and so can I run them in parallel? So let's look at what happens here. Here I have a promise. Here I have a promise. Here I have an array of 2 promises. What happens when I call await on an array of 2 promises? When you call await on anything, then you get a immediately settled promise for this array, because it itself is not a promise, it's an array. And so this doesn't work. This doesn't give you anything useful at all. So what you do have to do to make this work is you have to put a promise.all in here. And so the way we do that today is we call promise.all. Now in this case here, we are going to get an array of a 10 and a 20. The question is, when are we going to get it? We're going to get it after 2000 milliseconds. Yeah, and one day we may be able to elide this promise dot here and do it like that. I am so wrong. I am so wrong. Over here, we called await, and then we called await, and I said, well, the first await has to be done. So this happens after 1000 milliseconds, and this happens after 1000 milliseconds. Over here, there is no await. So this promise gets produced right away. The function call returns immediately. Immediately then schedules the second one. So this only takes 1000 milliseconds. So let's go through some more confusion here. So here let's first of all see if I have questions. No. Here I take an array and then I use map. And so what do I get? Well, it depends on, so I get the value of 10 and the value of 20 under my function, which is a promise. So I get an array of 2 promises. Let's do this. Here. Here's my array of 2 promises. Okay. What do I do if I call await here? Well, the syntax tells me this thing here is a promise for a number. When I call await, I get a number. So I must get an array of 2 numbers. Okay, first of all, I have a oh, I'm supposed to type it over here. No. Okay, well, I think that's a confusing error, and I'll do it over here and see what gets better. This is it's a bad error message because the problem is nothing to do with parentheses. The problem has to do is that I'm calling await here inside a function that's not an async function. Let me declare it as async. Okay, so I'm not even, So I've confused node here, so I'll just tell you in the interest of time. So in this case here, let's see what now happens. You really now have to understand what's an async function do. An async function is a regular old function that returns a promise. So what I now get is I get an array of 2 promises, namely these 2 promises here. So this thing here with an async and await here is the exact same thing as what you have over here. And so now you can see that map is not super useful with async functions because you don't get the functions executed on the map elements. You just get the promises for when they will be executed. So what I'm doing here is I'm now saying, okay, I want to multiply each of these elements here. So when I get them, I want to square them. And this isn't going to work at all because now I have an array of promises and then I call map on it and you can't multiply these promises. And so the whole intuition kind of breaks down here, that you kind of think that with async await, you get the thing soon enough, but with higher order functions, it doesn't work. So that is a drawback of the syntax. Now, the final question, and that's a subtle question, but it's useful to think about, is here. So I have a try catch where if the image doesn't get loaded, I want to return a broken image. Over here, I return the load image promise. Over here, I return await of the load image promise. And I said before, there's really no difference. You can do this because the promise that we have over here is just going to pop out as a promise out of the async function. Every async function returns a promise. And when I call await here, well, that's an actual image, and it'll actually be wrapped into a promise again. So either way, I get this promise here, and it's just a syntactic question. But when you have a try catch around it, it's slightly different. And so it depends on what happens when load image fails. In this case here, if load image fails, then what I get is a rejected promise as the return value. And this broken image thing, this catch here, will never grip. Whereas over here, the await will try to turn the promise into a value, and that will fail when this promise is rejected, and the catch will grip. And that, I guess, is another good reason that I say that inside an async function, if you do have a promise and you want to do any further work, it really is always a good idea to call await on it, because then it does what your intuition tells you to do. It interacts with the correct control flow. But it is a super subtle difference, and so the only way to decode what that difference is to actually understand what promises are. Okay. So here's what I just said. And so, like I said, it's always what you want to ask is what is returned and when is it returned. So I have another module here about doing async iteration, but I don't think I'll be able to do it justice in 15 minutes. And so I'll just leave you with the slides for that. And it actually is not something that's super important. What I do want to tell you is, no, I don't, actually, I will tell you this. So I'll give you this refresher and I'll tell you why it's potentially interesting for implementation. But if your eyes glaze over, don't worry about it if you've never seen this before. So there is these things called generators, and a generator has nothing to do with promises, although as you see in a minute, it does. A generator is a kind of a function, but it's not a real function. It's a function that can run, and then it can suspend itself. So here you have this generator. The function star tells you that it's such a magic function. And it has a regular loop, and then it yields I. What that means is that it kind of gives out I as if it returns, but it doesn't quite return. It sits there, and then one can later re-invoke it. One can go back into the middle, and then it keeps on going. And So what it actually does is just like an async function is being transformed into something, a generator function is being transformed into an iterator object. And when you call next on that object, then one gets back into the flow of execution in the middle of the function. So you can you call this function. What you get back is actually an iterator. Every generator function returns such a thing, and then you call next on it, and each time you get the value that was done on the yield. So what's nice about a generator function is it takes, if you have a sequence of values that needs to be computed in a loop or in a recursive process, and you want to have the answers one at a time, then you can call yield each time you happen to find a new answer. And so it's easy to write a generator function. And then when you call it, of course, you have to call it by calling next to harvest all of the values. Now, there is another twist to generators, and that is you can throw things inside. So here, let's look at this function. I have a loop where I'm giving some value max, and I say, while I've not yet reached the maximum, I'll compute another value. And in the end, I'll have some computed. Okay, that sounds weird. And notice this yield here. I'm yielding the sum that I have so far, but I'm also using this inside the loop for the future. So what happens here is when you call next, you can put in a value in, and then that value gets then used as the value of the yield expression. So you can harvest a value out, whatever the value behind the yield is, and then whatever you put in here then gets thrown in here. So you can kind of talk to this loop in two ways. You can get a value out of the computation, and you can add a new one in. It's not super intuitive, but this is something that's been implemented in JavaScript for quite some time, and it was purposefully put in there to make it possible to implement async functions. So an async function, here I have an example of an async function, is actually translated into a generator, and where each of the awaits turns into a yield and the async turns into a function star. So and it is confusing. I'm not going to go into the details here at all. I just want you to know that that is what goes on under the hood. So a JavaScript engine knows how to do generator functions, and async leverages that knowledge. So if we had more time, we could go through this in gory detail, but I won't. All right, so let me come to the conclusion here so that you get the takeaway from this. Let's first see if there's any more questions here. Yes, so someone said this looks like generators in Python. Of course, it's exactly like generators in Python. Python absolutely came first, and so it really was put into JavaScript not because, I mean, sure, generators are useful, but it was a complex feature. And the big payback from generators really was that they knew that generators are the avenue to async. Everyone wants async. Really what everyone wants is a wait. You know, wait is this godsend that lets us not think about promises too hard. And so generators were the way to get that into the language. All right, so conclusion. The first thing to remember is JavaScript, you can't block. You're never allowed to say, let me just wait for this result to be there and then move along. You have to do your thing quickly, get out of the way so that the next thing can happen. So that's why every long-running task in JavaScript requires a completion callback. You want to get something from the internet, you have to wait for the answer to come back. You want to get something from the database, there has to be a callback that deals with the result. So absolutely everything that takes more than an instant will deliver its result in a callback. That's how JavaScript is like. We hate callbacks within callbacks. We don't want them. And so what Promise does is it gives us a better API that avoids the nesting of callbacks. So it gives us a way of representing this mess of computation in a fairly understandable object. A promise object stores within it the function that kicks off the computation and the functions that get invoked when the results are available. And so the promise has been purposefully designed to have a good API. And the API is very simple. It's then and catch, okay, and finally. But it's a simple API. The only pitfall you have to remember is that the argument of then is a function, a promise generating function. The argument of catch is a function. Just make sure not to put in non-functions in there. Would it be nice if that would just give you an error message, but you have to watch out for it. Then the promise API gives us these 4 functions to combine multiple promises. This is the only way that you can get them to run like all together and harvest the answers in a systematic way. So there's all and race. All does an and of the promises. Race does an or of them. And then there's the 2 somewhat more useful variants, all settled, that deal with, what if one of them is failed, or any that's a little bit more convenient than race, in that it'll give you one that hasn't failed, if there is one. Whereas race, if one would give you the first failure if it happened quickly. And so promises are fine, except when they get complicated, when you have more complex logical structure. You want to do branches or loops, or you want to catch exceptions. It's inconvenient. It's hard to read, and that's where await comes in. So every time that you have given a promise, say out of fetch or in real life, or out of like a call to a database, you'll always be given a promise, and then call await, and you get the illusion as if your program would wait. That means that the function in which you do that, you have to tag it as async. And you might now have the consequences of that other functions might need to get tagged as async. In the first iteration, you probably don't have to think about it. But when things get dicey, you do have to know how to reinterpret these asyncs as promise. Yeah, so when working through any confusing situations, ask yourself, what is the outcome there? Is it a value? Is it a promise? Is it an exception? And when does it occur? Does it occur right then as your function is running? Very probably not when you deal with async scenarios. Does it happen, when the promise is settled? So you really want to answer these questions. Yeah. And trivia fact of the day, async is implemented with generators. You don't actually have to know this. And so we didn't get to the async generators. They're interesting, but it's not something that you normally want to use. I mean, await is what you want to use. That's the drug of choice. And so everything else that I've been talking about is so that you can safely and competently use it. That's all I have, with a few minutes to spare. So if you have more questions, yes, there's a couple more questions. So, doesn't await block code? Okay, and I will say this one more time. I should have put this on the slide. Await does not block. All await does is it arranges the code so that later the right things happen in the right steps. So when you call await, it rewrites your code to a then on the promise. And then doesn't block either. All that then does is it registers the callback. So that is, and I'll go through this one more time because it is super, super important. So let me find some code here with loading image, a single image. I'll just do this code here. So here, this thing generates a promise. This thing generates a promise. When I call append images with 2 URLs and an element to append them to, the call to append images returns instantly and immediately. And what it does is it returns with a promise that is being carefully built up to do the following, that the load image promise is constructed, and it is given a handler that when that promise finally succeeds, that the rest of the code, which is all of this stuff, that then gets executed. In that handler, a second promise object is constructed, which will only happen after the first one settles. But nevertheless, append image does not wait for anything. You call append image, it instantly returns. You have the illusion as the programmer that the waiting happens, and it's often safe to think about that, but it's not always safe to think about it. So you always want to have back in your mind, yeah, you can kind of think about this, that a wait kind of waits. And it's the right intuition. The intuition will almost always be correct. But you still, at the back of your mind, in complicated scenarios, you need to know that there's no waiting. JavaScript never waits. All that it does is it assembles bits and pieces of your code so that later on they get constructed in the right order. So I'm hoping I'm hammering this into. All right, so someone asked about promise all settled and promise race. So promise all settled, there's a slide for it. I'm trying to find it, because I did kind of race through that, no pun intended. What all settled does is, instead of giving you an iterable with all of the results, it gives you finer grained information about success or failure. So let's look at promise.all. If any of the promises failed, the whole thing fails. And you don't get to see any of the successful results. With all settled, what you get is you get an iterable, like usually an array, of objects that tell you exactly what happened with each of them. It's either a fulfilled one, in which case you get a fulfilled and a result, or it's a rejected one, in which case you get an object that's where the state is the string rejected, and you get the exception rate. So yeah, then you iterate through the thing, and you can say, okay, this one was good, this one failed. So you want all settled is if there's at all the possibility of partial failure, and you need to then harvest the partial success. If you only care about complete success, then you can use all. All is clearly much simpler because you get an array back instead of an array of the things that you want, instead of an array of structures that contain the thing that you want, or not, in case of failure. So what about race? Race will give you the first thing. Race is actually not super desirable. Race will give you the first thing back that settles. But what if it failed? What you normally want is you want the first thing that succeeded, and that's what any gives you. So I started with race because that was the earlier of the function, but you normally want to use any. Okay, now it says, okay, generators are used with, yeah, I'm sure generators are used somewhere, right? What about the new? Okay, oh, I see, we have a new here, okay. When creating new promise. Okay, again, I would like to reiterate that you are super unlikely to ever create a new promise. It's not common that you have an existing async API and you need to wrap that into promises. But if you do, then, so what if you don't put, well, first of all, this thing is not right? You're calling here a new promise of resolve reject. That's not what you do. You're passing it a function, and that function has 2 arguments. If you never need to call reject, you can omit that, like in the case of our produce after delay. Okay, and what about the new? So yes, this new here would be required if in fact you did need to construct a promise. Let me reiterate, it's not likely that you need to do that. Okay, I think that gets us to the end here. It's 1 minute before 7. So I'd like to thank everyone for all the many questions that you had and for participating. I hope you enjoyed it. If you have any further questions, then please send me an email. I should be easy enough to find on the internet.